No, sir.
Am I audible to you? Anyone? Yes, good evening to all.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Yes, am I audible?
Yes,
Yes,
sir.
sir.
Yes. Okay,
Yes,
fine.
sir.
As continuation to the previous classes, now we are going to discuss one more new unit. So I am going to share that unit. Just people be wait. I'm going to share the PPT. Yes. Is it visible to you?
Yes, sir.
Yes, sir.
Okay,
Sir.
fine. So now one more black, that is quantum chemistry. So we are going to discuss about the new topic, that is quantum chemistry. So before the discussion of quantum chemistry, we need to know about how the quantum chemistry will be introduced, right? So before introduction of quantum chemistry, what will happen, right? So somehow classical mechanics will be there. The quantum and classical mechanics were applicable for micromolecules and macromolecules as well, right? So whenever we are going to discuss the properties of, just 1 second. Yes, back to the class. Right. So what is the classical mechanics? What is the quantum mechanics, right? Why we are going to discuss about quantum chemistry in M.Sc. level, right? So those things just we'll see. Classical mechanics that should be applicable for the macromolecules whenever the molecule will be very big in size, right? The velocity, momentum, position, and energy all those parameters of macromolecules can be determined easily. So the problem was arises when it is applicable to the microparticles like proton, neutron, and electron. So whenever we are going to discuss about the microparticles like proton, electron, and neutron, how they are assembled in an atom, right? So then what about their dynamic properties? All those things will be explained with the help of quantum chemistry, right? So quantum chemistry especially applicable for the microparticles like proton, electron, and neutrons, right? The various properties of microparticles are going to explain with the help of utilization of the concept in quantum chemistry. One right. So the properties of like position, mass, velocity, momentum, energy, radius. These all are dynamic properties. These dynamic properties for micromolecules can be explained with the help of quantum topics, right? So previously, according to the classical mechanics, right, the position and momentum of the any macro particle that should be determined. For example, a cricket ball will be there, right? So as all of you know, the cricket. So whenever the bowler bowling to the batsman, right? So ball which will be thrown to the batsman. So we can recognize where the ball position is there and what is its velocity. So simply we know 149 kilometers per hour speed. Then the position also we can recognize. So that means the position and momentum, both properties can be determined at a time for macromolecules. So that is explained by classical mechanics. So the classical mechanics was described by Sir Isaac Newton, right? So according to classical mechanics, the position can be determined as x is equals to x only. So here, whenever we are expressing with the cap, that is a symbol of cap, right? Any property that should be indicated with the cap, that means an operator in quantum mechanics, right? So here x cap nothing but x is the position, the cap nothing but it can be acts as an operator. So further we have operators topic we'll discuss. The momentum according to classical mechanics K is equals to mv, and the total energy of the macromolecules by addition of both potential energy as well as kinetic energy. So therefore, E is equals to half mv square plus v. So this is applicable for the classical mechanics. But these same parameters like position, momentum, and energy cannot be applicable for microparticles like proton, electron, and neutron. So therefore, the new concept was introduced. The quantum chemistry was introduced to explain the various dynamic properties of micromolecules like proton, electron, and neutron, right? So therefore, the quantum mechanics that should be described with the help of various principles like Planck's principle. So the basic principle is the Planck's. The energy of any microparticle is directly proportional to its frequency. So that is E is directly proportional to mu, or E is equals to h mu, right? Like Heisenberg uncertainty principle, de Broglie's principle, Schrodinger equation, right? Combining of all equations, by solving of that all equations, we can get the solutions of like various dynamic properties for microparticles. So this is the somehow brief introduction of quantum chemistry. According to quantum mechanics, the position itself can be denoted as same x is equals to x only, but the momentum will be, according to classical mechanics, momentum p is equals to mv. But in case of quantum mechanics, whenever the momentum, we are going to measure the momentum of the microparticles like protons, electrons, and neutrons. So therefore, P cap is equals to h by 2 pi I into 2 by rho x. So this is the equation may utilizes to measure the momentum of the microparticles. And also the total energy becomes kinetic energy and the potential energy, the sum of kinetic energy and potential energy. The kinetic energy according to quantum mechanics can be written as minus h square by 8 pi square m into del square, plus potential energy can be written as V. So therefore, this is the total energy. This is the total energy of the system, right? So therefore, we can conclude that according to a quantum mechanics, it is impossible to determine the position and momentum. So means the position will be x and the momentum will be p. So the both x and p can be determined simultaneously for macroparticles. Macroparticles means large particles, that is explained by quantum mechanics, classical mechanics. So the concept of macroparticles means large particles, that should be explained by classical mechanics. But the position and momentum cannot be determined simultaneously. So this is applicable for the microparticles like protons, electrons, and neutrons. Protons, electrons, and neutrons, right? So that is conclusion by application of various equations in quantum chemistry for microparticles. So then with the help of application of all those things, we are going to find out the dynamic properties of microparticles, right? So this is the introduction to the quantum chemistry. With the help of that, various parameters will be there. So we are going to discuss all those parameters in this chapter. Yes, are you able to understand? Yes, sir. Is there any difficulties? You may post it question in chat box only, right? So don't unmute yourself. Don't create. Don't make noise, right? So if any doubt or any disturbance will be there, just simply you may raise your hand in chat box, or else you may post a question. Okay. Yes, is it clear? Yes. Any one or two persons enough. No need all, right? So because sometimes my audio was reachable to you or not. I want to just confirming that thing, right? Okay, right. Here one of the topic will be there, that is a black body radiation, right? So important topic, black body radiation. So what is the black body radiation? We all people know this one. So whenever the black thing will be there, so that may absorbs 100% energy and also emits 100% energy. Whatever is the system may absorb 100% heat energy. So then that may emits 100% heat energy. That type of things we may call as black body, right? So black body radiations. What are the types of what type of radiations will be there? How the black body holds entire energy or else absorbs 100% energy. What will happen? What internally, what internally it takes place, right? How the possibility of 100% energy absorption in black body things, right? So we'll see. So this is the system, just able to see the diagram, right? So here like two circles will be there, right? So I want to draw this one, right? So right, see this is the circle, right? So which is a circle, it should be coated with platinum black, right? This is a circle that should be coated with platinum black, or else anything you have to take the surface of that object may coated with platinum black, and there is a chance to enter the light radiation into the black body system. So here it is a teeny hole will be there. So teeny hole is nothing but, so there is a chance to enter the light into the inside the black body. Whenever the light will be entered into the black body, so that will be involved in various transactions. This is the one transaction that will be reaches to the one of the position inside the black body, then again that should be reflected, right? So again that should be struck at one place and again reflected. Like this various number of transitions are takes place inside the black body. So due to involving in various number of transitions in inside the black body, so the whole material will observe or uh, observe the light radiation, and that should be hold inside, right? So that's why the 100% light should be observed by the black body due to the involving of various number of transitions, right? So these all transitions which are takes place inside the black body, so that can be explained how many number of transitions will be there, and with respect to all those transitions, how the black body hold the entire light radiation, that should be explained with the help of Planck's theory. With the help of Planck's theory. So just see, so Planck's theory explains, right? The black body emits the light radiation discontinuously in the form of packets. Whenever the light was observed by the black body in the form of electronic transitions, but the emission of the light from the black body is discontinuously, so that should be in the form of light packets. Means some of the energy will be released in the form of packet, and there is some little bit gap, and some another energy will be emitted in the form of one more packet. So like those all packets, right? So those all packets considered as quanta in quantum chemistry. So means according to Planck's, the amount of energy is emitted from the black body is directly proportional to the frequency of light radiation. So what the Planck is observed, right? So the black body will be there. So this is the absorption of black body. The light absorption will be there. That is due to the electronic transitions. That is absorption. But whenever the emission of light radiation will be there, that should be takes place in the form of packets. In the form of packets. How much amount of light will be emitted, and the energy of this emission will be directly proportional to frequency of light radiation. How much frequency of light was observed by the black body. So that is E is directly proportional to nu. So that is E is directly proportional to nu. So therefore, if we can remove the proportionality constant, if we can remove the proportionality constants, we can write E is equals to h nu. Here E is the energy, h is the Planck's constant. So then nu is the frequency. Nu is the frequency. But this energy should be quantized. Means the emitted energy in the form of packets should be quantized. So what is meant by quantization energy means that should be applicable for various numbers, right? Various numbers, that is E is equals to, we can written as NH nu. E is equals to, we can written as NH nu. Here n is equals to 1, 2, 3, so on. If n is equals to 1, that is the ground state energy. That will give ground state energy. N is equals to 2 means 2h nu. That will give first excited state energy. N is equals to 3 means second excited state. Like that, various number of electronic transitions we will get, right? So then, according to Rayleigh-Jean's principle, right, that energy can be expressed with the help of average energy. Means the emission energy E can be expressed with the help of average energy. This is the equation. So that is E is equals to 8 pi by lambda power 4 into E bar. Therefore, this value should be substituted in above equation. Energy E is equals to h nu will be there. E is equals to h nu. That is according to Planck's equation. Instead of this E, we are going to substitute this equation. So we will get one new equation. So that equation may express, right? So this is the equation may express, right? So then E bar will be there. E bar is the average energy. The average energy of the particle that should be obtained from the Planck's theory. Therefore, E bar is equals to h nu by e to the power of h nu by kt minus 1. Just you people make it right, this equation, right? So here not a proper equation, means representation was not in proper manner. So here E bar is equals to what we have to write means, first of all, write h nu. All of you make it right. H nu divided by e to the power of h nu e to the power of h nu by kt e to the power of h nu by kt minus 1. This is the equation, right? So means here some this is the not complete divided by, this is the complete divided by only. That's why E bar is equals to h nu by e to the power of h nu by kt minus 1. So here you have to show, right? You have to see. Therefore, the energy is equals to 8 pi by lambda power 4 into h nu by e to the power of h nu by kt minus 1. This is the equation is applicable for how many number of transitions are takes place inside the block body. How many number of transitions are takes place inside the block body. The various number of transitions are takes place inside the block body. With respect to that, the block body material may holds 100% energy. So 100% energy, and also that should be emitted 100% energy, right? So this is the thing is about block body radiation, right? Block body radiation. Simple. You people have to remember. Means any object that should be coated with a platinum black and it has a teeny hole to enter the light into the inside of the block body. Whenever the light will be enter, the various electronic transitions are takes place. So then after that, the energy will be emitted from the block body. That emission in the form of packets only. Discontinuously emitted energy, that is in the form of packets. Each pocket we may call as quanta in quantum chemistry. each quanta can be represented as with A is equals to h nu, nh nu. Then the energy emitted energy will be quantized. After that, by the application of Planck's equation, according to Rayleigh-Jean's equation, we can get one equation, that is equation number 4. Therefore, this equation is applicable for how many electronic transitions are takes place inside the block body, with respect to that how much percentage of the amount will be held by the block body and how much amount of energy will be emitted from the block body. Right? So is it clear? Yes. Yes, ma. Is it clear? Just you people want to give response.
Yes, sir.
Yes, sir.
Okay. So the black body radiation was important for exam point of view. So you people may understand that black body radiation and so how the entire material may holds light and emits 100% light energy, right? So all those things just to keep it in mind. And after that, some equations will be there like de Broglie equation and some other equations like Eisenberg uncertainty. So these all are the fundamental basic equations. So no need to much focus. Just we have to idea about these equations, right? Okay, fine. Then, so de Broglie equation, right? All of you know, I think this de Broglie equation that will be in BSc level or intermediate level will be there. According to de Broglie, so we are saying that so this is the nucleus containing protons and neutrons, right? And the electron which will be revolving around the nucleus, Whenever the electron will be revolving around the nucleus, this electron may possess dual nature. The electron may possess dual nature. One is the particle nature and other will be the wave nature. One is the particle nature and other will be wave nature. What de Broglie concluded that so whenever the electron which will be revolving around the nucleus, at the time the electron may possess dual nature, right? So one is the particle nature and another one is the wave nature. So this particle nature and wave nature will be supported by Planck's equation and Einstein's equation. So therefore, according to Planck's equation, E is equals to h nu. Then according to Einstein's principle, E is equals to mc square. So therefore, from these two equations, h nu is equals to mc square, we have to write. So, but nu is equals to c by lambda. That's why this c by lambda should be substituted in place of nu. We will get hc by lambda is equals to mc square. Therefore, lambda is equals to h by mc. Here c is the velocity of the light, that is 3 into 10 to the power of 8 meter per second or 3 into 10 to the power of 10 centimeter per second, and m is the mass of the electron. So this is the equation. Sometimes this mc means velocity, we may use it as v or represented with v, that is velocity of the light, mv. mv is equals to, we know, that is the momentum. So therefore, here we may written as lambda is equals to h by p also. We can written as lambda is equals to h by p. So that is the equation, is the de Broglie equation, right? So simple you have to remember, whenever the electron which is revolving around the nucleus, that electron must possess dual nature. One is the particle nature and other will be the wave nature. These are supported by Planck's and Einstein's, right? So therefore, A is equals to h nu and A is equals to mc square. Then after simplification, we will get lambda and p, momentum and wavelength relationship. Momentum and wavelength relationship, that is the de Broglie's equation. So this one already we discussed. If velocity is v, that is h by mv, mv is equals to momentum, that is p. So but we know that kinetic energy is equals to half mv square. Then multiplied with the mass on both sides. Here m will be there and here one more m will be there. This denominator 2 will come to the left hand side. So then that is 2m kinetic energy is equals to m square v square. mv is equals to p, we know that. Therefore, p square is equals to 2m ke. Therefore, p is equals to square root of 2m ke. So therefore, with the help of that, we can write the equation of de Broglie equation, that is lambda is equals to h by mv or h by p. As some people are drawing lines, right? Hey, you people are not a kids, na? Why you are doing like that? Huh? Most of the people elder than me, right? So then lambda is equals to h by mv or h by p or h by square root of 2m ke. So this is the de Broglie equation. So what we are going to conclude, this means with the help of de Broglie, so the electron which is revolving around the nucleus may possess dual nature. One is the particle nature and other will be the wave nature. So whenever the electron possesses wave nature, we will get some data from that, right? That's why, so we are going to discuss about de Broglie's, right? So coming to the one more topic, that is the Heisenberg uncertainty principle. Heisenberg uncertainty principle, right? So as we discussed, why the quantum chemistry applicable for the microparticles like protons, neutrons, and electrons, right? So it is stated that Heisenberg uncertainty principle, what it explains means the position and momentum. Momentum is the p. The position is x and momentum is p. The both position and momentum of a microparticles cannot be determined simultaneously. The both position and momentum cannot be determined simultaneously. If we can determine the position accurately, the momentum will be infinity, that is uncertainty. Or else, if we can determine the momentum, the position will be infinity, that means uncertainty. So these are the two cases. Right? So which will explain with the help of Heisenberg uncertainty principle. And that principle may express in the form of equation, that is delta x into delta p is greater than or is equals to h by 4 pi. So instead of p momentum, we can write mv. So therefore delta x by delta v is greater than or is equals to h by 4 pi. Yeah. So here we need to remember the thing, the position and momentum cannot be determined simultaneously at a time in case of micromolecules like protons, neutrons, and electrons. Okay. So this is the Heisenberg uncertainty principle. So this equation, this cases means if the position can be determined accurately, then the momentum will be uncertain, that becomes infinity, right? If we can determine the position, momentum will be uncertain, or else if we can determine the momentum accurately, the position will be uncertain. So that's why the position and momentum cannot be determined simultaneously This was proved by application of the commutation property, right? So further, we will discuss some properties. With the help of that commutation property, we are going to prove that so we cannot determine both position and momentum at a time, right? Then the Schrodinger wave equation will be there. So actually our entire quantum chemistry that is depends on Schrodinger wave equation only. We have a clear-cut idea about this Schrodinger wave equation, then only you will get understand the topic of the quantum chemistry. Otherwise, you are not able to understand the topic, right? So the complete topic that should be depends on the Schrodinger wave equation. So what is the Schrodinger wave equation? We'll see. With the help of utilization of all those principles, the Schrodinger will be defined one equation. With the help of solution of this equation, we will get some of the dynamic properties of the micromolecules, right? So therefore, Schrodinger wave equation can be written as whether the particle which will be moving along with three directions, right? So means x direction, y direction, then z direction. Whether the molecule which will be moving along three directions, right? The Schrodinger wave equation can be written as dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v is equals to 0. Here psi is the wave function, m is the mass of electron, h is the Planck's constant, e is the total energy of the electron, and v is the potential energy of the electron. So therefore, this we can written as with the help of Laplacian operator. This is delta means like this. This is the del only, right? You people know laptop, del laptop. So this is the del symbol, D-E-L-L. This is the symbol of del. Del symbol means that is what? Laplacian operator. So Laplacian operator. So therefore, del square of psi plus 8 pi square m by h square into e minus v into psi is equals to 0. This is the So this is the Schrodinger wave equation. So here the del square will be written as del square will be dou square by dou x square plus dou square by dou y square plus dou square by dou z square. So that is we may call as Laplacian operator. Laplacian operator, right? So these are the somehow fundamental equations. With the help of that fundamental equations, we are going to discuss the topics in our quantum chemistry. So the major topics was operators, right? So some postulates of quantum mechanics will be there, 5 postulates will be there. That all 5 postulates, one of the postulate is the postulate number 2 that will explains any physical observable property of micromolecules that should be considered and acts as an operator in quantum mechanics. Like so any plus symbol will be there. This is called one of the operator in quantum mechanics. If it is minus will be there, that is also operator in quantum mechanics. It is multiply will be there, that is also operator. It is divide will be there, that is also operator. Or else square will be there, even this is also an operator. Or square root will be there, this is also an operator. Or d by dx and d square by dx square will be there. These all are mathematical entities. The mathematical entities are operators in quantum mechanics. So what are the various type of the operators? With the help of operators concept, what we are going to get some properties, we'll see, right? So simple, first of all, addition operator will be there. Addition operator. As we know, addition operator means simple add. A is an operator. Two operators here we are going to take. A and B are the operators. Whenever cap symbol will be there, that should be considered as operator. A and B are the operators. Take one function that is f of x. F of x is a function, right? Now add these two operators, a plus b into f of x is equals to, we can write a into f of x and b into f of x. That is a plus b into f of x is equals to a into f of x plus b into f of x. Any operators, choose any two operators, one function, the two operators by adding and operating on that function, that is equals to the individual operators or operates on the functions, and by adding that result, the both will be same. Therefore, A and B are the addition operators. We are going to say that A and B are the addition operators, right? Simple addition. For example, I am utilizing here A is A, right? What is A is a operator means, for example, 2, right? So B is a operator means that is a 3. A and B are the 3. This is the A and this is the B. Okay. Simple in numericals. Operator is the X function, that is what? F of X is equals to X. Now we are going to operate this. 2 is operates on this function. You will get 2x. Okay. Plus 3 is operates on this function. We will get 3x. The overall becomes 5x. Overall becomes 5x. Or else 2 plus 3. Both are operates on this function. 2 plus 3 means 5. 5 is operates on that function means that is a 5x. Therefore, we can say the A and B are the addition operators. Is it clear?
Yes, sir.
Yes. So like that, simple examples will be there, right? So whenever we are going to say that whether the A and B are the addition operators or not means that should be satisfies this following condition, right? So whatever is the two operators and one function, the two operators or operates on that function, we will get the result. The sum of that result is equals to initially add two operators and the obtained results is operates on the function. So that is simple here. Some simple example will be there. So therefore that we can call it as addition operators. Somehow next multiplier subtraction operator will be there. Same, instead of plus you will get minus, right? So that means a minus b into f of x is equals to a into f of x minus b into f of x. If any two operators, you may consider the two operators are operates on this function f of x. If we satisfies, means those operators are satisfying this condition, we can say that the two operators are called as subtraction operators, right? So these are the simple things, as you know, people, right? Additions and subtractions, just you have to remember the condition only. So whether the condition was applicable, just we can say that that is addition operator or subtraction operator. The same phenomena in multiplication operator, right? So the A and B are the two operators. A into B into f of x is equals to B into A into f of x. That is the thing, means this is the f of x function will be there. First you may operate the B. B is operates on this function. You will get some result. Again A is operates on that result. That is A into B into f of x is equals to. First you have to operate the function is A on A is operates on the function. You will get some result. Again the B will be operates on that result. So there finally we'll get the result. This result is similar to this. So therefore A into B into f of x is equals to B into A into f of x. Whenever the two operators are satisfying these two conditions with respect to that particular function, therefore we can say the two operators are the multiplicative operators. Multiplicative operators, right? So you people be ready with a pen and paper. So because I will give some problems. you say that whether it is a particular operator or not, right? So not this simple. Further, we will get some difficult operators. So on the difficult operators, I will give some numerical problems. Even they may come in examination also, right? Okay. 3 operators, simple operators are over. One is the addition, there will be the substitution, then other will be, sorry, addition, subtraction, and multiplication, right? So now we are going to see one more operator, that is the linear operator. That is the linear operator, right? So A is an operator, and here we need to utilize two functions. Choose two functions and one operator. That one operator operates on these two functions. First, the operator operates on this function. We will get some result. The same operator operates on other function. We will get some result by combining of the two results. So that should be equals to individuals, right? So that is the thing. That is the thing, right? So here A into, this is the function f of x plus g of x. Two functions are there. Initially add those two functions. Then operator operates on that function. We will get some result. And operator A operates on individual functions. Function 1 and function 2. That is f of x and g of x. So that will get same result. So therefore, we can say that A is a linear operator. And also one more condition will be there. A into C into f of x is equals to C into A into f of x. C is a constant. Any constant parameter will be there. That is not involved in that operation. That will be take aside. Means that will be put aside and the remaining will be involved in operation function, right? So therefore, any operator that should be satisfying these two conditions, we can say that the operator becomes an linear operator. The operator becomes a linear operator, right? So here I am going to give one problem, right? The operator A is d by dx. A is what? D by dx. The function was f of x is equals 3x and g of x is equals to 5x. Now you have to say that the operator A is a linear operator with respect to these functions. Now check it. Conditions are here only, right? So with respect to these conditions, A means in place of A, right, d by dx. F of x means 3x plus g of x means 5x. 3x plus 5x means 8x. D by dx of 8x, we will get the result is 8 only. Okay. Then A operates on f of x. F of x is the 3x. D by dx of 3x means we will get 3, right? Then plus again A operator, that is d by dx operates on the 5x. We will get 5. 3 plus 5 means 8, right? The first condition was satisfied. Okay. Here C is equals to 5 will be there. Right. A into C into f of x means A means d by dx. C means 5 into f of x means 3x. This 3 will come front side. 5 3s are 15. D by dx into x is equals to 15. We will get 15 of this left hand side. We will get 15 of this left hand side. Then right hand side also same we will get. C means constant means take outside. A into f of x means we will get 3. 5 3s are 15. Therefore, we can say that the operator A d by dx is a linear operator with respect to these particular functions. The d by dx is always not a linear operator. With respect to those functions, that becomes a linear operator. Without a proper function, without a proper operator, we cannot say anything, right? So whenever we are saying this operator is so and so, with respect to the function only. If there is no function, we cannot say whether the operator is so and so. Is it clear? I think I'm thinking you people are following the class, right? So almost 26 members are there, right?
Yes, sir.
Yeah. So it will be little bit difficult, but you may fully concentrate on this class. You will get some, right? Clarity. Right. So the same will be there. See, 8 is equals to 8 means first condition was satisfied. Then second condition 15 is equals to 15. Second condition also satisfied. So therefore we can say that the d by dx is operator is a linear operator with respect to the functions f of x and g of x. Okay. Right. Coming to the one more operator, that is vector operator. Right. So previously we discussed that Laplacian operator. So but here the vector operator. So the vector operator will be denoted with del. This is the del is the vector operator. Del square is the Laplacian operator. Right. So remember, right. Some people are raising hands. Yes, tell me. Please yourself unmute and ask. Some iPhone person is there. Yourself unmute and ask. Right. So in between the class, don't waste the time. If you have any reason, you may raise your hand. So otherwise, don't disturb the class. Right. So vector operator means only del, which contains I, J, K values. Means vectors. X, Y, Z are the axes and I, J, K are the vectors. So in the sentence itself, vector operator will be there. I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So I, J, K are the vectors, x, y, z are the axes. So therefore del square means del into del. Del dot del. Del dot del. So means here del means I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Similarly, one more del. Here we need to remember, so no need to multiply all those things. So we have to know the condition, that is I dot I, j dot j, k dot k is equals to 1. Means the similar vectors will be there. So the dot of similar vectors means multiplication of similar vectors is equals to 1. I dot I, j dot j, k dot k is equals to 1. I dot j, j dot k, k dot I is equals to 0. So therefore, we will get I dot I, right? The remaining two becomes 0 because I dot j, I dot k, the two are 0. We'll get one term. J dot j will get one more term. K dot k will get one more term. Only 3 terms we will get. So that is the expression of the Laplacian operator. That is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Del is the vector operator and del square is the Laplacian operator. Right? These are the simple operators. Now we are going to see somehow complicated operators. So one of the operator here we are getting, that is Hamiltonian operator. Here two terminology will be there. You people want to remember. One is Hermitian operator will be there. Hermitian. The other one will be Hamiltonian. Right? So two different will be there. Hermitian and Hamiltonian. So we will get complete idea based on these, right? So now we are going to discuss Hamiltonian operator. Hamiltonian operator. So it is very simple operator. It should be expressed with the help of Schrodinger equation only, right? So just we'll see. Right. So Hamiltonian operator. Right. So what is a Hamiltonian operator means? Schrodinger wave equation will be there, right? Schrodinger wave equation that is del square psi plus, this is the plus symbol, ma. Just make it correction, not equals to. Here also plus symbol. Acha, this will be equals to minus. There is no plus symbol in the second one. Only first one will be the plus symbol because equals to 0 is there. Equals to 0 is there. Okay, right. So here, Schrodinger wave equation. If we know the Schrodinger wave equation, we can get easily Hamiltonian operator. Del square psi plus 8 pi square m by h square into e minus v into psi is equal to 0. This all will become outside, means that is del square psi is equals to minus 8 pi square m by h square into e psi minus v psi. So these terms will be, means this entire term will be moved left hand side. So the right hand will get e psi minus v psi is equals to minus h square by 8 pi square m into del square psi. Even this v psi also will go to left hand side. We will v psi is equals. Therefore, e psi is equals to, we will get this equation. Therefore, we can write e psi is equals to minus h square by 8 pi square m into del square plus v. This is the total energy. We already discussed previously. According to quantum mechanics, the total energy will be, this is the kinetic energy and this is the potential energy. Previously, first slide will be there. There we mention, according to quantum mechanics, the energy will be this one. This is the kinetic energy and this is the potential energy. The sum of these two will give total energy. These total energy may called or considered as Hamiltonian operator. Hamiltonian operator. That should be explained by third postulate of quantum mechanics. So third postulate of quantum mechanics, according to that, the Hamiltonian operator H cap is equals to minus h square by 8m square into del square plus v. Del square plus v. So this is the Hamiltonian operator, right? So quite somehow different operator will be there. That is a Hermitian operator. So that we'll see. So before that Hermitian operator, we have the concept of eigenfunctions and eigenvalues. Eigenfunctions and eigenvalues, right? Yes, are you people able to listen the topic, some more topic? It's been almost 1 hour 10 minutes, right?
Okay, sir.
Shall I continue?
Okay, sir.
Continue, sir.
Yes, sir.
Huh?
Yes, sir. Continue,
Okay,
sir.
sir. Continue.
Okay.
Yes.
Okay.
No, sir.
Just one topic only. So because so the further coming topics are important for exam point of view. So what we explained, that one that may utilizes, but these are the most important for exam point of view. So definitely we need to concentrate on these topics, right? So you people may keep aside if any work is there. So just little bit focus. So we'll discuss this topic, eigenfunctions and eigenvalues topic. So further, so the remaining topic will be continued in the next class, right? Okay. So be patient and be listen, because I will give some numerical problems based on these eigenvalues and eigenfunctions. If you able to understand the topic, you can do it easily. You can do it easily, right? So if you won't understand this topic, it is difficult to get the solution of eigenvalue of those functions. Okay, right. So simple, see, whatever is the matter will be there. You forget about that. Just take one operator, that is A is an operator, right? A is an operator. And one more function. So here one function will be there, that is the f of x. F of x is the function, right? So one function will be there, that is the f of x. A is an operator. Function is the what? F of x. This operator is operates on this function. We will get same function. What we have initial function will get same function, but multiplied with some constant value. We will get same function multiplied with some constant value. Therefore, this particular function we may call as eigenfunction. The particular function we may call as what? Eigenfunction. The operator is eigenoperator. Eigenoperator, right? So then this value is eigenvalue. Eigenvalue. Just remember, only one operator and one function are required, right? If that operator operates on that function, we will get as a result of same function. For example, initially f of x is there. So in a result, we will get x. That should be multiplied with any term, any parameter. So that is considered as the value only. That value becomes eigenvalue. The corresponding wave function is the eigenwave function. And the corresponding operator is the eigenoperator. Eigenoperator. So is it clear? So just
Okay,
a little bit focus, right? So much focus is needed here. So because these topics will be repeatedly come in further concepts, right? So see one more time. So I'm going to explain. A is an operator. F of x is a function. When the operator A operates on the f of x, which is equals to the same wave function multiplied with some constant value. So here A is a operator, f of x is a function. We'll get same f of x multiplied with some constant, that is the lambda. This lambda is the eigenvalue. The corresponding wave function is the eigenfunction. And the corresponding operator is the eigenoperator. Eigenoperator. So this is the concept of eigenfunctions and eigenvalues. Eigenfunctions and eigenvalues, right? So you people may take one notebook and pen. So I will give some. Yes, ma. Yes.
Voice is not clear, sir.
Voice not clear.
Yes, sir.
Okay.
Breaking.
Other people are getting same problem?
No, sir. Clear.
No, sir.
Clear.
It's clear or not?
Clear, sir.
Clear, sir.
Okay,
Clear,
fine.
sir.
So there may be problem was there only, right? It's not from my side. Okay, fine. So you people take one paper and pen. Just I will give some numericals. So then you have to find out the eigenvalue, right? So I will explain one problem. So the remaining will be I will give just orally. You people have to write. So just see here. Find the eigenvalue of A is the operator. What was the operator? D by dx. Function is what? Phi x square. What is the function? Phi x square. Operator was d by dx. Now A into f of x means d by dx into phi x square. D by dx into phi x square. Phi will be kept constant. X square becomes 2x. We'll get the result was 10x. By operating of operator on this function, we will get was 10x. But our function is what? Phi x square. There is no x square in the result. Therefore, that is not a eigenfunction. Therefore, that is not a eigenfunction. If we will get same function in the result, then only we can say that is a eigenfunction. Right? The first problem was clear? Yes. This first one was clear or not?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So the second will be there. We'll see the second one. Right. So find the eigenvalue of. Find the eigenvalue. You don't see there. Just you take paper and pen. I am giving the operator that is d square by dx square and function was sin x. Sin x is there. Operator d square by dx square is there. Right. Simply the operator is operates on that function. Right. So see here, this is d square by dx square into sin x. D square by dx square means 2 times differentiation will be there. So here 1 time, the another time differentiation means d by dx of sin x. Therefore, d by dx of this sin x differentiation was cos x, right? Again, d by dx of cos x will be there. Therefore, that is equals to minus sin x. In a result, we have sin x. Our function was sin x only. Here also we are getting sin x, but it should be multiplied with minus 1. This minus 1 be the eigenvalue. Minus 1 be the eigenvalue. Same function we are getting, that is the sin x. We have the function sin x. After operation of these operator on this function, we are getting the same function with multiplied with some value, that is the minus 1. Therefore, we can say that the operator is a eigen operator and the corresponding wave function sin x is a eigen function and the eigenvalue is minus 1. Right? Is it clear?
Yes, sir.
Yes,
Yes.
sir.
Right? So somehow numerical problems are there, right? So these are the somehow numerical problems means function operator is d square by dx square. This is function is e to the power of kx, right? So then find out whether it is a eigen function. If it is eigen function, what is the eigenvalue, right? Then after that, complex function and normalization, orthogonality, well-behaved wave function, Hermitian operator, commutation operator. Other 5 topics will be there. That other 5 topics will may discuss in further class. Okay. So you people just want to read these notes immediately after the class. So whatever work is there, you people may spend some time. Right now, I will send the notes in the group. Just you go through it. What are the topics today we covered, right? So then only you are able to understand the topics, further topics easily. So without this knowledge, you cannot understand the further topics because so simply by the application of normalization rule, I can say. So you have to know idea about normalization rule. So based on the eigenfunctions and eigenvalues and eigenfunctions, so we will get some conclusions, right? So that's why you have to know idea about all this terminology. I think these all are the basic terminology to understand the concept of the quantum chemistry, right? These all operators and remaining all topics are the fundamental terminology to understand the further topic of the quantum chemistry, right? Is it clear?
Okay, sir. Thank you.
Yes, right. So I am going to conclude the meeting. So I will share these notes in the group itself. You may go through the notes. And if you have any doubts, we will be discussing those doubts in the further class. Means immediate tomorrow class will be there. So we will discuss in the tomorrow's class. Okay.
Okay, sir. Thank you.
Okay, sir.
Okay, fine. You people may join in further class. Class is there next?
Yes, sir. It's there. Math class.
Yeah. You people may join in that class, right? Okay. I'm going to conclude the meeting.
Okay.
Thank you, sir.
Right. Bye. Take care.
Thank you, sir.
Okay.
Thank you,